Yeah, hi everyone. So today's topic will be about powering secure transactions with MC technologies. So MC stand for multi-party computation. It's a complex technology that most people don't have a solid understanding of. So today, hopefully, I will clarify some, and introduce and provide more knowledge about MC technology. So first, before deep we dive into MC technologies, we need to discuss about the landscape of custody and asset protection. So usually we have two form of custody. First is self-custodial. So self-custodials usually start with a single signature wallet, like software wallet, which the wallet that we mostly use, like a Phantom, uh, MetaMask. They are pretty easy to use, very user friendly. However, there are some problem with single key software wallet. The big problem is that it's super prone to hacks. So most of the hacks are happening due to the compromise of the single key wallet. And another disadvantage of software wallet with some wallet like Phantom is that there's no row separations and it's super difficult to share securely. And it's not recommended to use like Phantom in the context of a business. Let's say that you have a team. It's not recommended that you share a private key with the members in your team because if a hack happens or any malicious withdrawal happen, we can trace who initiated the withdrawal. So it's very hard to trace who's execute the transaction if we share the private keys. Also, another problem with those wallets is that it's lack transaction policies, which is something smart account can solve, but it's kind of similar to the problem of multisig wallet. I will discuss later. Next is hardware wallet. Um, we have some providers like Ledger or Treasures. The problem with those hardware wallet is that it's not 100% secure because there are no attacks to hardware wallet like side channel attack, supply chain attacks. So supply chain attack mean that you bought, like for example, you bought a Ledger wallet from eBay, and there's case that you just bought a Ledger wallet from eBay, and then years later, all of the assets in his wallet was ran and hacked. So his loss of his assets that is well of millions of dollars. So the root cause is that he's bought a compromised hardware wallet from eBay, right? So a hardware wallet is had its own problems, and when you buy a hardware wallet, you must be sure that it must come from a trusted and authentic provider, and make sure that that device not tampered um, during the like packaging to your home. Also, the next problem is that poor usability. It's not user friendly for new blockchain users, especially new users that just learn how to use um, wallet. It's very difficult for them to understand the concept of hardware wallet. Um, Next, we have a different wallet architectures that require multiple signers. So multi-sig as smart contract wallet. There are some providers like Swat on Solana, Safe on EVM chains. Um, multi-sig wallet is much more secure than traditional single key wallet. Um, yeah, but the downside is that it's chain specific, which what it only works on Solana and not compatible on EVM chains. And it's also difficult to integrate with Web2 technologies. And if you want to implement like some automation workflow for your business, um, it's very difficult to do so and integrate with multi wallet to do that. Multi wallet is good for treasury management, but to be able to offer automation workflow is still kind of limited. And yeah, that's a very big problem of multi wallet. Also, another problem is that the process to replace the signer is very painful in a company. Let's say that your company had multiple wallets, like 10 wallets, and then an employee like the CTO or the CFO leave the company, then you need to remove all of his asset on all of the wallets. It could be painful to do. Yeah, so that's also a problem of most wallets. The next kind of custodial is um, custody is custodial, usually provided by crypto exchange. This mostly for end users, like what we usually use. And another form is crypto custodians, which is mostly used for institutions, like customer that want to deposit large fund and they need to like have insurance on their fund. So there are some providers like BitGo, Fireblocks, Coinbase Custody that provide crypto custody service for institutions. Yes, so we just cover the landscape of custody, and next we will discuss about MCs. So MC is also another form of wallet. So MPC is technologies that allow multiple parties to compute a resource together without exposing individual secrets. So it's not something new. It's just been around since 1980s from a paper called How to Solve the Millionaire Problem paper. However, it's mostly under academic form and until 2017 when there was a big bull run in the crypto market, more and more companies started to experimenting with MPC technologies to implement distributed key generation. And then until now, it has been widely adopted by many crypto exchanges and custodians. There's some characteristic of MC wallet. First is that private key is never constructed in a single place, and whenever we need to generate a wallet, it needs to go through a process called distributed key generation. Right, so the private keys never in one single place. So there's no single point of failure, and MC was compatible with both ECDSAs and EDDSA curves. So there are some algorithms like ZZ18, ZZ20s, which are used for Bitcoin, Ethereum, Frost for Solana, Polkadot, and there are some open source implementation. The most popular one is TSS Lib, which is developed by Binance, Zengo, and many more. TS Lib, I think, is the most stable and popular one currently. Yeah, so next we discuss about distributed key generation. So to be able to generate a MC wallet, there will be multiple nodes that will participate in a cluster. Usually, a cluster have three or more nodes, and all of them will participate in the key generation. So key generation in MC will happen through multiple routes, and it leverages multiple cryptography techniques. First is VSS, mean verifiable secret sharings. It's a variation of Shamir secret sharing, which allow nodes to distribute secrets securely, and let other nodes verify those secrets. Um, ZKP, which is under technique that allow the nodes to share secret, to prove that they are doing computations correctly without revealing their secrets. Also, another technique called homomorphic encryptions will allow you to do computations on encrypted data. Yeah, so it's involved a lot of complex and advanced cryptography techniques. So after a key generation event happens, the key will be distributed into shares. So each node will have will store its own shares, and the private keys is never constructed in a single place. So next, it's come to the signing part. So it's also called threshold signature scheme, TSS, where you need to involve multiple nodes to be able to generate and compute a signatures. So usually when we set up an MC node cluster, we need to set a threshold called T, and to be able to produce a signature is require T plus one nodes to sign. So um, here it must follow a formula that T must be less than n divided by 2, take the root only. So let's say that for a cluster of 3 nodes, if we want to have at least 2 nodes to participate in the signing process, then we must set T equal 1, because we want T plus 1 node to sign. This means that T must be 1 to be able to less than 3. Um, yeah, so we're at the signing phase. All 3 nodes can participate in the signing process to produce the signatures, but theoretically, it's only required 2 nodes. Depends on the signatures, right? So it's optional for this node to participate in the signing process, and nodes will coordinate to be able to compute the signatures. Um, Okay, so we already covered key generation and for producing the signatures. Next is about recovery. So how, if like the share on any of these node is like is lost, like let's say a node is corrupted, and like this is corrupted, and uh, how we can like recover the keys, right? So there is a technique called resharing in MC wallet that allow us to regenerate the shares of the keys without changing the public key, right? So let's say that's this node 2 is compromised, or like is corrupted for like physical issues, right? Then we can spin up another node, and we can run resharing protocol to reshare the shares of the keys, right? So shares 0 will be transformed to share 0. Um, uh, no one's redistribute is set 1, while node 3 redistribute is set 2, and this node will be leaving the cluster, right? So but the good thing is that the public key doesn't change after this resharing, right? So if you already have the access in the wallet, and then we need to run the resharing protocol to be able to regenerate access, then it's okay. Your access will not be affected as the public key doesn't change. Yeah, so there are multiple different MC setup. First is that the commonly used usually 2/3, which is being adopted by some crypto exchange like Binance. They have something called Web3 wallet, right? So it's running MC under the hood. And how it works is that the Binance will keep share number 1, and the user's device will have the share 2 and share 3, right? So it may require 2 shares to be able to initiate the transactions. So because Binance only have single shares, can never initiate the transactions. It must require the share from the user's device as well. And for like redundancies and backup, it allow you to back up the share tree onto some cloud storage like OneDrive, Google Drive. Um, Another architecture is that 2/2, which is currently used by Django or Circle. My Circle have developer control MC wallet. So how it works is that the Circle we have 1 share, we keep 1 share, and the developers server we keep another share on their nodes. So to be able to initiate a transaction, both parties, both Circle and your nodes need to coordinate to be able to initiate a transaction. Another architecture is that 2/3, so 2 shares will be keep on the server side and client only have one. So this is mainly used for custodians with insurance like BitGo, Fireblocks. So this is users don't want to mess up with backup recovery process, so they delegate to the custodian side. Yeah, so those are the most architectures, most popular MC wallet architectures that we usually see in the market right now. Yeah, next, there's some challenge with MC wallet. First is that even though there are some existing libraries, it's super low level and complex to set up, and it requires expertise to develop MC wallet. Unless you are using some providers like Fireblocks, BitGo, even Circle, right? If you want to do MC wallet at scale, it's very expensive. Usually, it's costs around $500 to $1,000 a month, which is not affordable for most small Web2 teams. And at first step, we developed an framework called MCM, which is built on top of TLS Lib. So we wrap TLS Lib, we provide the messaging layer and resiliency layer for MC stack, right? So you can run MC node very easily and effortlessly in minutes. So to discuss a bit about the architecture of MCM, so it's a cluster require of multiple nodes, right? So minimum you should have at least three nodes, and you can expand and add more nodes to the cluster as you want. But the more node you add to the cluster, the slower the signing or key generation process will become, because there will be delay during when like passing messages around between the nodes. Um, yeah, so there needs to be a balance between scalability and efficiency. In this cluster, we leverage consumer for service discovery, health check, coordination between the nodes. Um, Also, leverage NAS, resilient messaging layer. It's kind of like a mesh queue, right? So you can send event to this NAS queue, and then it's buffer the message. Let's say that you want to shut down the nodes for upgrade and maintenance. Then when clients send event to this queue for key generation or signing, it should buffer the message. And without this message passing to this will be short, because the nodes was already shut down for upgrade, right? So adding this will add more resilience to the system. So another component is client, which is also called event initiator. So this event initiator will send event to this cluster. Like it will send event like keygen, signing, reset event, and each event is tied with a signatures that is using the a key, and all of these nodes must be have the public key of the client, so that they can verify if the signatures is valid. And also between the nodes, there is also another verification layer that nodes must verify each other message, because those nodes need to coordinate um, process message of each other to be able to complete a key generation or signing event. So those are the high level architectures of MCMs. We open source MCM on GitHub, and let me go to how to run the MCM cluster. So we have this installation and run documentation. It's pretty straightforward, right? So you need to clone the GitHub repo. I will do it right now. So first, we just need to clone the project. and then I cd into the project. Now I need to run make to be able to build the binary of the programs. So the project provide two command line interface. First is MCM, which is used to run MC nodes. Another one is MCM CY, which is used to generate the configurations for the MC nodes. So before we can start the cluster, we need to have a NAS and console to run. Right? So I already have a Docker compares in the projects. So here is the Docker compares file. Just run Docker compares up, and then it will run NAS and console. I already run it, so I will not run it again. After that, you need to generate the number of peers that will participate in the cluster, right? So if we want to have 3 nodes in the cluster, we just specify dash n3 generate peers dash n3. I already generate once peer sessions. It's also default in the repository, so you don't need to run this command. It's optional, right? So it gives you 3 nodes with unique UUID. Okay, after you have the nodes configuration, you need to um, uh, create a config file. I already provided the config.yaml template. We just need to copy it. Copy config.yaml template into config.yaml, right? And then we should have config.yaml. So what I'm missing here is the Badger password. So under the hood, we are using Badger, which is a key value store to store the share of the wallet, right? So a good thing about Badger is that it's very minimalistic comparing to SQL database, and it's offer um, encryption address out of the box without you to install any extra add-ons. So it's pretty minimalistic. So that's why we choose Badger DB. Yeah, so you need to provide a password for the encryptions. Usually, um, you don't need to provide it in the config file. It's not a good practice. For in production, you need to you are not allowed to input it in the config file, but must provide through the command line interface. Right, so should avoid providing any sensitive credentials in the config files is prone to hacks. Right, so for development it's okay, but in production environment you should not input sensitive value into the config file. On production we have different deployment setup, so just follow the tutorial. For now, for development purposes, I just provide a password here. So to be able to generate a password, copy this command. Sorry. I copy the password over here. Okay, next thing is that you must register peers to console so that console knows that all these nodes, how many nodes will participate in the cluster, right? So I just execute a command. There will be 3 nodes that will participate in a cluster. Next is that you must generate the initiator configuration. As I mentioned earlier, there will be an event initiator. So what we will do is that MCM CY generate initiator. In production, you should enable the encrypt mode so that it will ask you to provide a strong password to encrypt the private key of the initiator. So after you run this command, we have 2 files, event initiator and t.sessions, which contain a public key and another private key that is encrypted in production environment. If you don't provide the encrypt flag, it will not be encrypted. It's fine for development purpose. And the next step is that you need to run the command to generate the configurations for the each node, right? So you must do that for 3 nodes. Um, so I already have a script to do all this step quickly. So it can be used for development purpose, but on production you should follow up a step recommended in the documentation. All right. So first is we'll run the command setup identity.sa. I need to run the execution role first for this file. Sorry. Setup initiator.sa. So after I run this command, identity file is generated, contain a public key of the initiator, and then the private key for now is development purpose, so it's not encrypted. Yeah, it's warning that you should use encrypt flag for production environment. Next, I will generate the configurations for the nodes. Run identities, run setup identities.sa. So we will see the nodes folder is created. Node 0, 1, node 1, node 2. If we refresh, we will see 3 node folder here, right? And each one have this configuration, the public key of the event initiator. Also in the identity folder, we have the public key, the identity file of other nodes, and also the private key associated with this node that is used to sign messages. So yeah, basically we have a already configure everything of the MC cluster. Now it's time to run the actual cluster. So first I will cd into node 0, and then I will run npm start node 0. You should provide debug flag if you want to see everything in the logs. And then we do the same for node 1, npm start node 1 debug. And finally, node 2. Okay, it's waiting for the third node to boost up. Yeah, so every node in the cluster is ready. We will see a message called all peers are ready. So it's ready to accept the events from the initiator. So back to the architectures, we have the client event initiator. So we provide the SDK or client in Golang and TypeScript. So to be able to make it friendly for developers, we'll run some tests with the TypeScript client, right? So you need to go to MCM client TS to download the example code. I already downloaded previously on master branch, right? So here we have the example folders that have some sample code for generate a MC wallet and sign transactions. So before you can interact with cluster, you need to create an event initiator key. In production, it will need to require you to provide the encrypted version, and also you need to provide a password. So I will create an event initiator.key file, right? And then I will need to copy it from the previous configuration that I generated earlier. So I will copy it from here. And then after you have it set up already, so let's take a look at the code, right? So first that you need to initiate a connection to the NAS and also provide a connection to the client and the key path. In production mode, we have -a um, extension. So this is encrypted, and you need to provide a password. So passwords usually come from secure vault like Hashgraph vault or AWS KMS. So yeah, so after you create a client, it's just some code to store the public key into the wallet JSONs. Don't worry about it. The next thing is that you need to register an event on wallet creations, which is receive an event keys and success. So it will contain a wallet ID, each stays public key. It is a public key. So you only receive the public key and you will not receive any private key at all, right? And the shares of the key will be stored on the MC nodes. And the client don't store, will not receive any sensitive information except the public key. Yeah, this on wallet creation result is pretty straightforward, and it's pretty simple to create wallet. You just call create wallet and provide a wallet ID, right? So the wallet ID could be anything. Usually you need to use you can provide UUID as the ID of the wallet. So I will run npx now, generate wallet. So I can generate 10, depends on the how many wallet I want. Just for testing purposes, I just generate one wallet now. And yeah, you can see that a wallet is generated pretty fast. And if we take a look closely at the nodes, we can see that during the key generations, there are multiple routes of communications. First is for EDDSA and then ECDSA, right? So during a key generation, there will be multiple routes between the nodes to be able to coordinate and generate a wallet. So what is returned back to the client side is just the public key and the wallet ID, right? It says no information about the private key or any other sensitive information. Next step is the we will do is transaction and try to execute the transaction with the MC wallet that we just generated. So we run TSS node. Sorry, I should explain about the how to interact with the signing APIs. So it's pretty similar to how you compare a transaction with Web2.js. You just need to initiate a client similar to key generation, right? And then similar to key generation, you also need to register an event on sign result, right? So sign result will contain a signature and the wallet ID, so you can compare these unsigned transactions, and then later on include the signatures and broadcast to the blockchain. So for instance, I will want to transfer some Solana to this wallet, provide the amount shown here, and then provide destination. Um, yeah, so in this transaction, I haven't signed yet. I need to register the on-site result first, and also I need to call a function sign transaction, provide a wallet ID, the key time. For Solana is Edward curve, so it's ED 25 519, and yeah, we provide a text, which is the binary of the transactions. Yeah, so we call side transaction, and after that, after the clients receive the signing result event, it should include the signatures in the transaction right here, transaction.s signature, and then it will broadcast to the Solana blockchain. Here's how we execute a transaction on the testnet environment. Um, so let's see this now samples dot site. Oh, sorry. First, before I can initiate transaction, I need to send some Solana to this wallet. So let me send through Phantom wallet here. Okay, good, good. So I can sign the transaction now. Just TS now a sample size Solana plus TS, and then we copy the wallet ID we generated earlier. So it's a flag provided into the program, right? Wallet ID as the first argument. So yeah, so we will execute a transaction, right? We can see that the signatures you return, and we can see the Solana transaction is executed on chain, right? 0.001 is transferred to this wallet, coming from the MC wallet that we generated earlier. So yeah, if we take a look at the log, we can see that there have been multiple rounds during the sign process. Um, yeah, so it's pretty fast for S-word curve signature. So yeah, because we set up the cluster with the threshold of 2, this means that it must require 2 plus 1 nodes, mean 3 nodes must all participate in the uh, signing event. Right? If we shut down a node, though 2 node is still available, but if we initiate a transaction, it will not work because it's require 3 nodes to be able to uh, um, execute a transaction, right? So if you want only 2 nodes to participate in the signing process, then we can change the threshold here to 1, right? And then update every configuration of cluster to 1, right? And then you need to regenerate a new wallet and yeah, sign again. So yeah, so that's pretty much it about the MCM framework to let you run MC cluster very easily and effortlessly. We also have the cloud version of MCM, which is we have a platform called FireStack, and yeah, you can basically create MC no or MC wallet pretty easily without the need to host up the infrastructure yourself. Right, so we provide the API keys so that you can create MC wallet, and also it has users management features, so you can invite multiple people into the workspace to manage wallet. So it's much more flexible comparing to multi-sig wallet, while you have programmable automation flow, right? So you can implement automation workflow on top of this MC wallet, which is something that not possible for multi-sig wallets. And also it has advanced security features like API, audit trails, TFA, analytics, everything that you need for treasury management, business operation when you're building application that require interaction with Web2 technologies. Yeah, so I think that's it for my sharing. I'm open to any questions from the community.
Yeah, okay. Um, I don't see any question here, but I have a question. As I understand, after we create the private key, this private key will never reconstruct. Is it correct?
Yes, but if you have all 3 shares together, right, you have access to all 3 shares. There's a way that you can reconstruct the key, but during the key generation, it's never constructed unless you intentionally do it after you already have all 3 shares.
Hmm. Okay, okay.
Yeah, so
And yeah, yeah,
uh,
yeah, yeah.
it's mostly used for emergency, right? And usually MC White don't let you to do that, and mostly just do resharing, right? Want you to back up the key, or like for some reasons they know it's corrupted, compromise, meaning we can like run resale protocol to distribute the new shares to a new node.
What is the new shares? The new share is a new part of the private key, right?
Yeah, it's a part of the private key, right? So previously the share two is on this node is corrupted. We can run resale protocol, and then share two will be regenerated on another node, but it's different from the previous one.
What who can run the resale process? Who can run
Uh,
it?
the event initiator can run the resale process, so it can run
Oh,
execute keygen signing resale.
mm, mm. But I mean with nodes for example I one node on circle and dev hot one node and then the dev want to reset or something like that. Can how I mean what node which node can run the reset or reset?
I think in the context of Circle, I think they will run resale, not from client side. Client just like submit an API to the Circle server, and then I think they have something called event initiator as well to send the resale event to the other MC nodes, and it's also coordinate with the MC node of the developer to run resale. um, yeah, so that how I understand about Circle MCU developer control wallet.
For example, Circle had one node and developer had one node, and then Circle just run the reset and does it change the set of the developer?
Yeah,
They just run the reset. They don't add the developer and they run the reset.
yes, they can, unless they have like something called end-to-end encryption. Like, it's like we can never like know 100% what is behind the scenes, right? They can say that only you can execute a transaction or initiate a transaction, but um, actually they have access to features called resharing, right? They can reshare the your key with another machine, right? And then um, after that, it's only required that new machine to coordinate with Circle server to be able to execute the transactions. Yeah, so probably Circle prevent that, but I'm not 100% sure. Yeah, so it's yeah, they need to go through a audit to prove that it's non-custodial, meaning that only you can initiate a resale event, and it's happened in a way that through end-to-end encryption mechanisms, right? Even though um, they can run resale, it might require permissions like your private key or something to sign a message. I can like imagine how it's worked like that. Yeah, I'm not 100% sure, but theoretically they can run resale without your consent and yeah, initiate a transaction. So there's downside of MC that is kind of a bit centralized comparing to most SIG wallets. That's the drawback that you need to pay when using MC wallet. Obviously, you can run self-hosted MC now. Yeah, to avoid those centralization issues, but require a lot of expertise and effort to maintain the MC nodes.
Yeah. Okay. Got it. Um, so I think there are no more question. Uh, okay. Okay. Thank you, Thi, for that informative workshop, and we hope to see you again in the future session with Super Team Vietnam.
Thank you, Mr. V. Thank you, everyone. Hope you enjoy this session and see you soon.
Yeah. Okay. I think I will show a bit about the current policy of Super Team Vietnam. because we have a LT, and I think some people will don't know about so I will say. Okay. If you are a dev, yes, Solana dev, and you are in the SuperTeam community, SuperTeam Vietnam community, currently we have two bounty. The first bounty is about the token 2022, which is transfer. Yeah, it bounty I think it's a big bounty with a very big prize pool. So if you are working with token 2022 and you build with the transfer hook, you can apply to this bounty. Yeah, it is very big bounty. And the second bounty is about a bounty for Super Team Vietnam community. Yeah, at Super Team Vietnam we have a lot of ideas to build on Solana. Yeah, it is about 19 ideas, but not all the idea to be can become the startup. And so what we need is that you pick three over 19 and you analyze this idea. How can we turn this idea into the startup? Yeah, this is the second bounty, and it's just about 1 day and a half remaining. So we apply to this bounty. I think it's not very complicated. It's easy for people in our community. And one more thing, we have a Solana Scam Hanoi version in 28 July to the 2nd August. If you are in Hanoi, welcome. We very welcome you to the Solana Camp Hanoi version. Yeah. Okay. That's all from me. And once again, I want to thank you everyone to join us today. And thank you, Thi. See you guys next week. Bye bye.